in your vocabulary, do you understand what it's going to ask you when it says revenue, cost, and profit? So, the revenue is how much your company brings in. So if you sell 2 cars for $50,000, your company brought in $100,000 that day. Big difference. 2 cars to dealership. But if those cars cost you $80,000, your profit is the difference. So you brought in 100, they cost you $80,000 to get on your lot. Your company profited $20,000. So the profits the profit would be the revenue minus the cost. So anytime anyone's starting a business, they're thinking, well, am I going to make a profit here? How much is it costing me to run my business? And how much am I going to be able to charge people? And what will my profit be? Is it worth it? Oh, this is coffee mugs. So this is lowercase r. The revenue from selling my coffee mugs. Can you guys determine, Max, you guys put your devices away and just keep them away in class. Can you determine how much this coffee store sold their coffee mugs for? $6.50. Their revenue was $6.50 times the number that they sold. Did you guys buy a coffee mug for $6.50? It's a hard no. Because it has a lid and a handle. A lid and a handle. Let's call it a travel mug. Travel mug. That's actually cheaper than travel mug. Maybe, yeah, maybe it's decorative. Alright, so then how much does it cost for me to make my coffee? Is it am I making this? Oh yeah, it's a ceramic store. I should have said. Okay, so I'm actually making these ceramic mugs. How much does it cost me to make a ceramic mug? Each time I make a mug, it's costing me 75 cents. And it's costing me $18.50 just to start making it. So perhaps this is to get like all of the well, just to open the shop. And then it's 75 cents is actually the clay that goes into the mug. Or maybe the person creating the mug, it's 75 cents for each mug they make. What does it say? 8. Okay, so then 1,850. So what could cost you 1,850? That could be your whole month's mortgage. So this could be the mortgage on the shop, and this could be the clay to make the mugs, right? So my profit is going to be 6.5x minus 75 cents for each mug, and the 1,850 it's costing me to run my shop. So subtracting functions, we practiced yesterday. We did adding, subtracting, multiplying, dividing, and your fifth operation is brand new, composition. Minus signs get distributed, like multiplying a -1 through. Which one?
I understood it in class though. And then I looked at it and I was like,
You guys are gonna see. It's just you just didn't have to do anything. You just make fraction. I mean, I think in one of them x is crossed out. But I got the work. We can talk about it. So this is 575. So the profit that my store is looking for is going to be actually 575 per mug sold. Take away 1850. So if it was a monthly profit, I would see how many mugs my sales associate sold, put it in here, subtract 1850, and that'll tell me my profit. So we have to find the profit for 500, 1,000, and 5,000 coffee mugs. That's a lot of production. So I'd love to see your work. Does it say letter A and letter B? So this is your answer for A. In letter B, show it like this. I'm going to say P of 100. No, 500 is the first one. And plug in 500 for X. And then I'm going to find the profit for 1,000. And so the number I'm plugging in for X goes next to the parentheses. So I like practicing this because it's good function notation work. And then the profit, if I have a huge sale, 5,000 mugs, that's like all of Publix bought my mugs and they're selling them. Whole Foods, like on Shark Tank, Whole Foods picks up my mugs and I sell 5,000 of them. I sure have. Everyone here's seen Shark Tank 1. Anybody here not seen one episode of Shark Tank? Look it up, guys. Look it up. Look it up. You've never seen Shark Tank? All right. So Alexis, did you plug any in yet? You haven't had anything. Emily B, have you plugged any in yet? No. Get your calculator out. I wasn't upset about your back. I was just calling on you. You got one?
That was 100. Not 5.
Oh, 500 is the first one.
Sorry.
No, it's probably my fault. It's probably my fault. Victoria? Emily H, do you want to just put this in your calculator and tell me the answer? No calculator. Matthew, do you have a calculator? $10.25, 3,900, 26,000. I'm hoping to make that sale for the month. Let's just say you need to sell more than 5,000 a year, okay? That's not gonna cut it. It's not gonna cut it. That'll get you a new kitchen almost. No, not even more. You can't get a new kitchen for 26. Yeah. Unless you're your own contractor. Okay. Furniture. Yeah, you're right. Okay. Get out your homework and let's answer those questions you have. Alright, so it's looking quite blurry here, so I'll have to redo it really quick. I'll let you know if I see it, okay? See. So most of these are just a lot more simple than they look. So on number 1, didn't I do one? I started it with you guys. We had the fire drill. F over G. You're supposed to leave x plus 4 over x minus 5, but you do need to state that in this problem, x cannot be 4. It would create an undefined fraction. For this, it says to do F over G. Well, this is number 1. You have to do them all. All 4. What's your question? Like for number 1, this is F and this is G. So you do F plus G, F minus G, F times G, and F over G. Okay. All right, let's do number 4. No, just because it's not squared, it's just positive. So for F plus G, you're just gonna write them like this, and since they're not like terms, there's nothing you can do. So leave it. F minus G, they're not like terms, so you subtract them. There's nothing you can do. Emily, what you talking about? You good? So now we'll do F times G. And so that's 3x squared times 5 over x. So that's like, this first function isn't a fraction, so I can put it over 1. 15x squared over x, and then reduce it, 15x. I wish you could say that every time a fraction comes up.
Yeah.
Alright, and then I'll do f over g, and that's 3x squared divided by 5 over x. Now this is a challenging fraction because it's a fraction in a fraction, so that's an improper fraction. So I'm definitely going to go back over this. 3x squared over 1 divided by 5 over x. Multiply by the reciprocal. Well, it's all about writing it horizontally. That'll help you remember. 3x to the third over 5. Yes?
Like I just put x and then I got 3x squared. Then just 5 on some.
Do you have 3x to the third?
Yeah, that one.
Yeah. Yep. Okay, any questions on 4 now that you've seen it? Or okay. And now 9 through 12.
We only did 9 and 11. You changed it.
Nice. G of h. 3x to the third over 5. Alright, so this time I'm plugging h into g, so that's going to be 2 parentheses x plus 2. That's 2x plus 4. And I'll go the other way. I'll plug g into h, and that just stays 2x plus 2. You might want to check this. You may have been tempted to write 2x squared. But this x goes out and the 2x goes in.
That's number 11, right?
So you guys did 9 and 11?
Yeah. Oh yeah, I didn't get no. Just eggs.
They're both just x, which is something special. We're actually going to talk about that quite a bit. Those means those are perfect inverses. We'll actually do a whole thing where we do composition of prove inverse, and if they're truly inverse, we simplify to x.
That's one. Where's the? Yeah. You just didn't write this one then. I did all of them. Oh, you only did those two. There's one operation. She definitely.
Alright, I just have to show you one other way these problems could look, and then we'll end class with that all work. Do a few notes. Hopefully they're clear. Alright, so composition of functions was brand new to you yesterday, plugging one function into the other. And so this is still just composition of functions. However, instead of the x being left, we're going to put a number in. And students generally find this easier. Because like you said yesterday with the X squared. These were questionable. You can look different ways. This one makes a little more sense. It's a lot like what we did for Bellwork when we plugged in 500 and 1,000 and 5,000. So when the problem gives a number here, see the number instead of an x? All of these have numbers instead of x. You plug the number into the inside function, you get that value out, and then you plug that into the outside function. There's more than one strategy, but that tends to be the most successful. So F, G, and H. So we're given three functions. One's called F, one's called G, and one's called H. And I also wrote this two different ways. Maybe you have the open circle, or maybe you have two sets of parentheses. Both presentations are common. Can't write on there, it's blurry. So for number 3, you start by finding G of 1. So in the words up there, I said the inside function. When I see all of this, this is the inside one, like the one, this would be the inside one. So first I'll do G of 1. What's that? Yeah, the one closest to it. So G of 1 is just 5 times 1, because I take the G function, I take the X out, and I put 1 in. So G of 1 equals 5. Oh, it's an open circle. Then you plug that result into the F function. So do the inside one, get a number out, take that number and put it into F. So now here's the F function. So now I'm going to do F of 5. So now I know that F of G of 1 gives the result 25. So the F function is x squared. So I took this answer and I replaced x with it. Alright, try this one in your group. Talk about what you think the best first step is. Yep, try for G of H. I'm plugging Did you find each of negative 2 yet?
Yes. Positive 2. And then you plug in that positive 1.
Number 4. So start with h of negative 2, and I look for the function called h, and I put negative 2 in for x, and I get the result of 2. Plug that result into G. So I'm very careful to pick the right function. G of x is 5x. I do that operation, and it could be much longer. It could be so complicated. If this was like a more complicated polynomial, these are pretty short problems. So I'm going to say G of h of negative 2 gives the result of 10. This whole thought process of composition is really important for programming, computer programming. Taking one function, taking that result and plugging it into another one, and that calls on the computer to do a whole different thing. It's like a chain